Welcome to my pre-algebra class. We're on chapter 12, section 2. We're going to be working with making sample spaces and tree diagrams. A sample space is a list of all possible outcomes. So I'm going to go to the internet to show you a few. And then a tree diagram. So here we have a sample space of rolling a die. If you roll a die, you have 6 possible outcomes. That's the sample space, 1, 2, 3, 4, 5, 6. Another common experiment is tossing a coin. The outcomes are heads or tails. Drawing a card from a standard deck, there would be 42 possible cards. Drawing a marble from a bottle. In this case, there are 8 possible outcomes. The blues, the 5 blues, the 2 reds, and 3 reds. And then rolling a pair of die, there are 36 possible outcomes. So that's the idea of a sample space. And then a tree diagram. In this case here, if I wanted to, I don't think it's going to want me to get there. A tree diagram is a way to show all possible outcomes by setting up a tree, basically. So if I wanted the sample space for tossing 1 penny and rolling 1 die, and so it'd be 1 penny and 1 die. Well, the penny I could have heads or tails, and the die I could, from after the heads, I could get a 1, a 2, a 3, a 4, a 5, or a 6. So my outcomes are heads 1, heads 2s, heads 3s, heads 4, heads 5, and heads 6. And the same thing happens with if I roll the die tail. So with the tail I could roll the die 1, a 2, a 3, a 4, a 5, or a 6. So I could get tails 1, tails 2, tails 3, tails 4, tails 5, tails 6. So I have 12 outcomes. And that's the tree diagram showing all of them. Okay, with that in mind, we're ready to do the assignment, and we're on page 546, and we're doing 1 through 22. So problem number 2. Well, in order to do number 2, we're going to have to do number 1. So go ahead and copy. We'll take the whole piece of paper for number 1 to get the diagram down. So just put 1 center of your paper. And it's 4 coins are tossed. Make a tree diagram to show the sample space. So I have 4 coins. The first coin could be heads. The second coin could be... Okay, the first coin could be heads or tails. The second coin could be heads or tails. And the same here, heads or tails. The third coin, I could have heads or tails show up here. Heads or tails show up here, and the same down here. Now the fourth coin, again the same thing, heads or tails, heads or tails, and continue. So you get that drawn on your paper, and we could actually write out the outcomes. This is heads, 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 tails. Sometimes it's just as easy to read through them. This is heads, heads, tails, heads, 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 tail, tails. And following the path here, we get heads, tails, heads, 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 tails, heads, tails. Then going down this path, heads, tails, tails, heads, heads, tails, tails, tails. And the second tree, we have tails, heads, 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 tails, heads, heads, tails. Now we're on this path, tails, heads, tails, heads, tail, heads, tails, tails. And this last path, tails, tails, heads, heads, tails, tails, heads, tails. And then the very last path, tails, 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 heads, and then tails, 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 tails. So we're hopefully going to come up with a different way of doing this, because that's going to take a while. All right, so problem number 2. Find what's the probability of exactly 3 tails. Well, I'll go back here and see which ones. By the way, there were 8 here and 18, there were 16 outcomes. So exactly 3 tails. There was 1 here, and down here there was 1, and there was 1 here. So exactly 3. Was there one more? Exactly 3. 3, and this one had exactly 3. So there were 4 out of 16. And then simplify 1/4. Problem number 4, 5 heads, probability of 5 heads. Well, there's no way that's going to happen, so that's 0. Okay, problem number 6, we have a new experiment. The number cube below numbers 1 through 6 is rolled and the spinner is spun. Make a tree diagram to show the sample space. So take the whole distance across your paper to do this. So we could get a 1, and then from that 1 we could get red, blue, or green. The 2 could have red, blue, or green. The 3, when we roll that die, we could then get a red, blue, or green on the spinner. The 4, red, blue, or green. The 5, red, blue, or green. And if we roll the 6, we could get a red, blue, or green on the spinner. So problem number 8, the probability that we have an odd number, and it's red. So if we go back, by the way, there's a total of 6 times 3, there are 18 possibilities, 18 outcomes. And odd numbers would be 1, 3, and 5. And red, there's 1 red, 3 red, and 5 red. So there are 3 out of 18. And then simplify it, that would be 1/6. Probability of getting a 7 followed by a purple. Well, there were no 7s and there were no purples, so that's 0. Number 12, the probability of not 5 and red. Well, the only die that's not 5 would be the 6. Excuse me, they're all not 5s except the 5. So, and it has to be red. So 1 red, 2 red, 3 red, 4 red, and 6 red. There are 5 ways to do that out of 18, and that can't be simplified. Problem 14, the probability of getting a 3 and not green. So if we go back to the 3, there was a 3 red and a 3 blue. So those are 2 ways of not getting the 3 green, not green. So there were 2 out of 18, which was 1/9. And number 16, probability of not 3. Remember, there were 5 of them that are not 3 on the die, and not red. And there was 2 of each of those. So it should be 10. Not 3 and not red. So here's 1 blue, 1 green, 2 blue, 2 green, and so on. So there are 5 times 2. There are 10 ways of that happening out of 18. And that simplifies to 5 nights. And the next section, we're to make a tree diagram for Dee's Diner, which offers customers the lunch choices as shown on the right. Customers can order a serving of meat, 1 vegetable, and 1 soup for 1 low price. And the customer is going to choose a meal at random, and we're going to find each probability. So this is we need to do the tree diagram first. So just put that down. We have, for the meat, we have chicken, fish, and beef. And chicken, we have a choice of peas or corns for the vegetables. And then for the soup, we have tomato or onion. And the same is true for, excuse me, the fish. We can bring the beef up here. And the beef, so we're actually kind of making a menu here. So problem number 18. So let's see how many total. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 possibilities. So number 18, the probability of a beef, followed by peas or corn, and tomato soup. So beef, peas, tomato, beef, corn, tomato, there's 2. Out of 12, which is 1/6. And number 20, the probability of not beef, well, that would make it fish or chicken. Not corn, that would make it peas. And tomato soup or onion soup. So not beef, we could have fish, peas, tomato, or onion. So there's 2 here. And here we could have chicken, peas, tomato. There's 2 here. So there's a total of 4 ways we can do that. So 4 out of 12, which equals 1/3. And the last problem, number 22. Whitney can choose an outfit from the following: 2 pairs of slacks. So we're going to have to make the tree diagram. So 2 pairs of slacks, navy or gray. 4 blouses, red, blue, striped, or paisley. And the same down here. 3 pairs of shoes, white, blue, or black. So from each of these, white, blue, or black. So there are 12 here and 12 down here, so there should be 24 altogether. So we have to do the same here. And the question for 22, gray slacks, so we're here, not red, so it could be blue, striped, or paisley, and not white. So we have 2 here, 2 here, and 2 here, so a total of 6 possible ways of doing that out of 24, which simplifies to 1/4. That concludes the evens. Be sure to check the back of the book for the odds.